Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on fats and oils. In our last lesson, we explained the general method of preparing esters, which is known as esterification. We learned that esterification involves heating a mixture of a carboxylic acid and an alcohol in the presence of a catalyst such as sulfuric acid. We also learned some common uses for esters. We discussed that esters are used in solvents, medicines, and clothing, such as polyester. We learned that esters are often used to create artificial flavors and fragrances. This is because of their pleasant, fruity smells. In today's lesson, we are going to describe the physical properties of fats and oils. We will explain the hardening of oils, which is the process of converting oils to hard fats. And we will explain rancidity. Let us begin with an activity. Students, when you think about oils and fats, what are some common characteristics that come to mind? Please write them down on a piece of notebook paper.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. I am sure you thought of some great common characteristics of fats and oils. You might have said that both fats and oils are good lubricants and that they are greasy. You might also have said that fats and oils are colorless and odorless. Another common characteristic is that fats and oils do not dissolve in water to form a homogeneous mixture. Imagine dumping a tablespoon of oil into a glass of water. The oil will not dissolve. It will just sit on the surface of the water. Let us continue discussing the physical properties of oils and fats. Fats and oils are not readily volatile. However, they can be burned without leaving behind any residue or ash. Fats and oils are both soluble in organic solvents such as benzene, ether, and chloroform. Some fats, such as butter, lard, and tallow, are solids when they are at room temperature. Oils, which are mainly obtained from plants, are liquids at room temperature. Some examples include corn oil, peanut oil, olive oil, sesame oil, and soybean oil. I am sure if you put your mind to it, you can think of many more. Oils can be converted to fats. This process is known as hardening of oils. Hardening of oils is achieved by adding hydrogen to oils, which is called hydrogenation. This is done at high pressure and with the presence of a nickel or palladium catalyst. Why would we want to harden oils? This process is used to manufacture margarine. Unsaturated fatty acids include oleic and linolenic acids. Saturated fatty acids include myristic, lauric, palmitic, and stearic acid. The unsaturated fatty acids can be converted into fatty acids using the hardening of oils process. A glyceryl tristearate, which is found in animal fats, can be prepared by hydrogenation of glyceryl trioleate. Glyceryl trioleate is oil that is found in olive oil and whole oil. The equation of that reaction looks like this. Students, let us discuss rancidity. Teacher, please divide the students into groups of 3 or 4. Students, in your groups, Discuss a time when you saw something that was rancid. Then, explain what rancidity is.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello, everyone. I hope you did not find this activity to be too unappealing. Rancidity is not a very appetizing subject. You might have thought of a time when you saw food that was spoiled, or a time when butter or milk had been left in the heat for too long. Fats and oils are quite reactive substances. Therefore, when they are stored in temperatures that are too high for a period of time that is too long, they begin to deteriorate and spoil. Spoiled fats go rancid. What happens to fats and oils when they go rancid? Both develop an unpleasant odor, which is caused by the hydrolysis of ester linkage and oxidation across the double bonds. Different fats go rancid in different ways. Some spoil quickly, while others take a longer amount of time to go bad. Either way, when fat goes rancid, it develops a very unappealing odor and flavor. Not all fat goes rancid as a result of being left out in unfavorable temperatures or conditions. Some fat is rancid from the moment it is produced. This can happen when fat is produced with ingredients that have already spoiled and are undergoing decomposition. To obtain a sound and sweet fat, the raw materials must be sound and sweet. Fats also must be produced in sanitary conditions and in a timely fashion before any of the ingredients has a chance to decompose. The fat that is produced must then be quickly stored in favorable conditions and consumed without delay. In today's lesson, we learned about the physical properties of fats and oils. We learned that both are greasy, colorless, and odorless. Fats are often solids at room temperature, while oils are often liquids at room temperature. We learned about the hardening of oils, or hydrogenation. This occurs when hydrogen is added to oils. This is done at high pressure with the presence of a nickel or palladium catalyst. We also learned about rancidity. This brings us to the end of our lesson for today. Until next time, thank you, teacher. Thank you, students.